everyone. Our project involved a coordinated and structured effort across three distinct technical phases, matching the key deliverables that were laid out in a rubric required for securing and analyzing modern web application. So I want to start off this video, just welcoming you to this video, and also just laying out what our group did as each individual member. So the division of labor was as follows. I handled the foundational infrastructure, which included configuring the domain name using no IP, and then also explain the detailed method for configuring SSL. And then Pranav went ahead and focused on security testing readiness, configuring SSL key logging, and demonstrating how to test SSL traffic in Wireshark. Then Alex closed it out by with some more analysis, really. He explained the capture of TLS traffic as well as analyzing the TLS traffic. So now I'll take you through the two essential phases that I completed, establishing our domain name using no IP, and then the crucial command line process of securing it with an HTTPS and SSL certificate. See here, I'll go to no IP real quick. If I can exit out. No IP. So the first task was absolutely crucial. You cannot continue on without setting up a human readable domain name for your website or registering it in the DNS system. So I'm going to show you here. I'm going to go to the dashboard. All right, dynamic DNS host names. All right, the first task was absolutely critical, transitioning our website from a temporary numeric address on an EC2 instance to a stable, readable domain name. Because of our AWS server using a static Elastic IP, we relied on the dynamic DNS service no IP to handle this vital domain to IP mapping and to ensure consistent accessibility. So now I'm on the no IP website right here, and right here you can see everything that I did here. So we started this process in the no IP dashboard by creating a new hostname record, which you can see as create hostname right here. The record is essential because it functions as an A address record. As you can see, I registered as an A record, which is the fundamental DNS entry that permanently links a domain name to a server's IP address. We chose the descriptive hostname money multiplier and appended the free domain tagline dot serveblog.net, which is right here. This defined our site's like permanent name. It fit our subject of what we intended the website to be, which I'll show you in a second. Crucially, we input our server static EC2 Elastic IP address, which is just 100.30.73.161. We put it into the IPv4 field. This means that every request made by a browser for our domain was permanently directed to our specific server. The successful creation of this record immediately registered the domain on the web, making the site instantly accessible via the domain name and completing the foundational work of phase one, which is domain name resolution. But I'm just going to quickly show you the website just so you understand why we went with Money Multiplier and then serveblog.net. So right here we have Money Multiplier, which is the whole website. It's all about kind of multiplying your money. Literally, it's in the name. And then we have a blog over here, which we can't access right now in the video. But if you went to our new website, which has HTTPS, you will be able to notice that. So I'm going to just go stay on this screen real quick. So with the domain linked, we moved immediately to the second most technical phase of at least what I had to do, because these guys had to do a lot. My part was just, it was great, just a very easy part just to set it up for them to finish it all off. So I secured the website with HTTPS using a free SSL certificate with Let's Encrypt. My work here focused on using the command line tool certbot to automate the deployment on our Apache server. Okay, so I'm going to go to I'm going to show you right where I did. So I obviously had to open up the instance right here. I used Connect to go into the CLI, which is the command line interface, where I was able to type in a bunch of commands and operate the installation of certain things throughout this project. I'm going to close all that out. Now I'm just going to show you what I utilized in this whole thing. Move myself down to the corner. All right. So the certbot tool is like the key to the method for configuring SSL. My goal is simple, which is to run the core certbot command and have it succeed. However, it took me multiple tries after troubleshooting two configuration issues. So installing certbot plugin, the process initially failed because I realized Apache was not it was missing. So I had to first install that right here. I installed Apache and I used the DNF package manager, which allowed certbot to install the plugin, interact with and modify the Apache configuration. Um, yeah, so then during the second attempt to install the SSL certificate, it failed because the CLI could not locate a virtual host on port 80, which was necessary. Uh, so I opened up a new configuration file and I put this virtual host block, which is right here, into that new configuration file, which allowed the server to start listening to port 80 in order for certbot to work on the SSL configuration. Um, so that once you exit that, you need to do a quick reset of the system or the server right here. So I did a sudo systemctl restart the HTTPD. Does a quick reset of Apache and makes it load up the new port 80 configuration. That what makes it what is making it able to finally follow through with the SSL install, where was able to finish up with sudo certbot apache d money multiplier dot servblog dot net, which initiated this SSL certificate request from Let's Encrypt, retrieved the certificate for it, and began its deployment. Um, so yeah, I just want to conclude my section on that note, covering the domain setup and also the successful HTTPS configuration. The secure environment is now fully established and ready for testing, which is why I'm going to hand it off to Pranav, who will discuss the configuration of SSL key logging as well as testing traffic and Wireshark.
Hi, I'm Pranav, and to enable SSL and begin the setup of our SSL keylogging for our website, first we verified the configuration of SSL onto our website through SSL Labs, which also showed the implemented TLS and SSL certificates from section 1. So as you can see here, we see the grade of A showing the presence of the certificate in the SSL report. And here we can see the specs. We can see a yes on certificate transparency and a yes on trusted. So after this, we moved on to this and we started the process of configuring SSL keylogging. So what we did was we went to the control panel as shown. We looked for the environmental variables. So we find out by searching of system and then go to edit the system environment variables. Once you are over here, you'd click environment variables. And we created this over here by clicking new on user variables for Pranav, which is me. And we named it SSL key log file. And I wanted to save it to my downloads folder. So that's exactly what I did. And we wanted to name it SSL keylog.log because it is a log file, which is used to store browser data in cache automatically by itself by the browser. And that's all we do. So it's meant to be populated once we started of Wireshark Wi-Fi capture and opened the HTTPS website. So how the log file works is that once we went on our website, the file was created and self-populated. When I first tried to populate the SSL key log.log text file, I created a separate file called SSL keylog.log, and I expected it to automatically populate without starting a Wireshark capture or opening browser, for instance. And what I didn't realize at the time was since the log file is intended to self-create and self-populate as a browser site or sites are loaded, so there's no need to create the file itself, just to add the user variable to my C drive through the control panel. In addition, the capture is necessary since we will input the log file into Wireshark later on in this presentation. So to begin, we closed all existing Google Chrome tabs. We started the Wireshark capture on Wi-Fi, and we opened the website with /wp-admin as shown over here. Open the HTTP as such. So we had administrator privileges. And then once we did that, we stopped the capture. Once the capture was stopped, I realized that our SSL keylog.log file was suddenly populated with all this data, all this log file from opening the browser. Once the capture was stopped, I checked the file it was populated, and these were auto-generated SSL keys created by the web browser. We then configured Wireshark to use these new SSL keys. Here's a picture of what I showed earlier. And here's the auto-generated keys again. Then we configured Wireshark to use these new SSL keys by going to protocols, we went to edit, preferences. And then we clicked on protocols, scroll down to TLS to implement it. Push down, a little more down, TLS. And then here, this is the pre-master secret log file name. I went to browse, went to downloads where it's stored, and I clicked on SSL keylog.log. And once I did that, I clicked apply. I clicked open, and then it was here, and I clicked apply. And typed in the IP address as such to show the files related to our website with the IP of 100.30.73.161. And we this decrypted the SSL traffic and shows results for HTTP, TCP, and TLS files related to our website. Inputting the IP address to filter the Wireshark traffic now allows us to analyze TLS traffic, which Alex will now go over.
Hello, my name is Alex, and right now I'm just going to be talking a bit more broadly about a couple of things. One is involving the TLS handshake, and then two is just more simply identifying and talking about some simple filters that we use to identify the traffic. So first, I'd like to start off by just explaining what the TLS handshake is and the steps involved. So what it's going to look like in Wireshark, a collection of different packets with the first one being the client hello packet. And this is just basically advertising and being identified by things like the TLS version. So as you can see here, we're using TLS version 1.3. Also like the cipher suites, which are just like algorithms that the key exchange follows, and then extensions like SNI. You can see that in the client hello packet here. And then following that is going to be the server hello packet. This is just the server responding to our client hello, just acknowledging and selecting that same information. So the TLS version and the cipher suit will both be confirmed in this step. And following that, it's going to send a digital certificate so the client can authenticate the server's identity, and so that it just knows that the right parameters are being met. An important thing to know is that just depending on TLS version, the server may also send key exchange parameters. So following this step, there's going to be the client key exchange. This is the main or one of the main parts of the whole ordeal for this TLS handshake. And this is where the client sends the key material. This is often or mostly including the encrypted pre-master secret or the key share. that both sides will use to generate the symmetric session keys. So again, just kind of setting the framework and making sure that both sides are on the same page. And then once the key exchange is complete, the client and the server each send the cipher, the change cipher spec packet messages, just indicating that they're both switching to the encrypted form of communication, which is ultimately what we're looking for here. Because the main point of the TLS handshake is to create a secure and encrypted line of communication between the server and the client. And then finally is the finished packet messages, just confirming that it was successful on both sides, the client and the server. And then at this point, we've ultimately achieved that goal of creating that secure and encrypted line of communication between the client and the server. And then to kind of explain what it looks like in Wireshark, just touching back on those simple filters that we used. So right here, we're just filtering by the IP address of the web server or the website. And then I'm just going to type in another simple filter here for TLS traffic, make it a lot easier to see. And then, so as I talked about before, we're going to first start off with the client hello packet. This is just, again, being identified by the TLS version, the cyber suites, and the extensions. So we'll see the extension SNI here, TLS version 1.3, which is going to be used throughout all these TLS packets, and then the cipher suites here, just, again, those algorithms for the key exchange to follow. Following that, we're going to come down here to the server hello, again, just mirroring that information. So version 1.3, and then also mentioning the cipher suites. So we see that it's using this specific one. And if we go back up here, we'll see that one as well. So just confirming on both sides. And then next step is the certificate. So the certificate, again, contains the server's public key, and the client uses that to basically verify the server's identity as well as prepare a key for encryption. So this is definitely one of the most important parts in the building the framework for the handshake. And then server hello done. So just the server is just signaling to the client that it's finished its part and it's waiting to generate the shared secret key. And then most important part, I would say, is the client key exchange here. So the client creates the pre-master secret and encrypts it with the server's public key from the certificate. The packet is critical because this packet is critical because both sides will use it to kind of create that those symmetric session keys for the encryption. And then we're going to move down to change cipher spec. So again, this is just basically the client telling the server that from this point on, both will be, or the client will be using the encrypted session keys. This is more so the moment where the encryption really begins. And then we're going to move down and towards the end of the process, where the server is basically saying that um, it received the client's encrypted message and the key exchange was successful. So this is obviously a sign of success here. And then the final step, again, is the change cipher spec finish packet. So this is just explaining that the server activates the encryption and that the transfer to the secure and encrypted line of communication between the server and the client is successful. Thank you.